Imagine a world without light. In the 18th century, Benjamin Franklin reintroduced electricity to the public through his famous kite experiment. His experiment with the kite included a kite with a key tied to the end of the string, which was connected to a Leyden jar. When the lightning struck the kite, the electric current traveled down the string through the key and into the Leyden jar. Many of you are wondering what in fact is a Leyden jar. Well, a Leyden jar is basically an old-fashioned battery. Leyden jars consist of a glass jar wrapped in lead foil with a lead foil lining. Going into the jar is a metal rod with a non-conductive cap. To store power inside a Leyden jar, electricity must be applied to the metal rod. The problem with Leyden jars were that they weren't extremely safe. Thomas Edison had a large contribution to the invention of electricity. Thomas Edison was the inventor of direct current electricity. Thomas Edison also invented many other useful things, such as the light bulb.
In the late 19th century, Edison had become a household name, known around the world. His inventions and innovations covered everything from telegraphy and the movie camera to the phonograph and the light bulb. By the time he was finished inventing, he held over 1,000 patents. He was brilliant at not only innovating, but also at business. Edison turned his inventions into commercial successes. In the case of the light bulb, he created a complete power system, generating electricity and delivering it to customers, energizing their light bulbs. Edison's system typically used a steam engine to drive a generator, creating direct current electricity. This is an Armington and Sims steam engine. Edison purchased hundreds of these to turn his generators. Steam engines like this were fueled with coal, wood, or oil. This miniature steam engine demonstrates the process. In this working model, electricity heats water, producing steam. The pressurized steam is controlled by a valve system to drive the piston back and forth. A connecting rod from the piston connects to a crankshaft. This device converts the oscillating linear motion of the piston to a rotary motion, turning the flywheel. A valve controls the speed of the engine. This is a generator. Permanent magnets surround coils of wire. The coils rotate in the magnetic field, inducing a flow of electricity. In this miniature generator, the electricity flows through the filament of a light bulb. A drive belt connects the flywheel to the generator. Once it is up to speed, the filament glows. Electrical energy has become light energy. Edison's generators produce DC, or direct current. This means that the current, a flow of charged particles, usually electrons, always travel in the same direction, from one terminal of the generator through the load, in this case a lamp, to the other terminal of the generator. Battery cells also produce direct current. Electrons flow from minus to plus. Edison built hundreds of DC plants around the world. He realized that there was a huge market for electric light. But there was one technical problem he had not resolved. The electricity lost energy as it traveled through the wires. Once the wires from the generator exceeded 2 kilometers long, there was not enough electrical energy left to turn on a light bulb. Every customer had to be within 2 kilometers of the power plant. This phenomenon was called line loss, a serious problem for Edison. There was no obvious solution.
Tesla started working on an arc lighting system for Edison, but it was never implemented. He left their employment shortly afterwards. There was talk of unpaid bonuses and disparaging remarks from Edison. Tesla marked his departure by scribbling across 2 pages of his diary, "Goodbye to the Edison Machine Works." Tesla founded his own company, Tesla Electric Light and Manufacturing, and established a number of patents. Even though it had the Tesla name, the reality was that the company was financed by 2 businessmen. When they decided to abandon manufacture and set up a new company, it left Tesla destitute and penniless. During 1886, he had to work as a ditch digger just to survive. He wrote at the time, "My high education in various branches of science, mechanics, and literature seemed to me like a mockery." However, Tesla soon got himself back on his feet with the invention of a new motor that ran on alternating current, or AC, which was eventually bought by Westinghouse. Tesla was a champion of AC and was hired by Westinghouse for $2,000 per month and given a hefty bonus. Westinghouse Electric Company was founded by George Westinghouse and based their technology on AC.
AC. Unlike DC, alternating current doesn't flow constantly in the same direction. It changes direction, surging back and forth. Alternating current is easily produced with a special type of generator, and AC has some very interesting properties. This surging back and forth motion of the current produces electromagnetic radiation that can induce current flow in adjacent but unconnected conductors. Tesla understood this radiation and perfected a device capable of changing voltage and current in an electrical system, the transformer. This changed everything. Suddenly it was possible to deliver electricity hundreds of kilometers using high voltage, low current transmission. The low current reduced line losses dramatically. The wires carrying the high voltage were suspended on towers at a safe height. The final step in this brilliant solution occurred when a step-down transformer converted the electricity back to a less dangerous low voltage with higher current for use in the homes and industries of the community. The relatively short distance from the transformer to the home meant that line loss from the higher current was minimized. Tesla had found a solution to the line loss problem. Edison realized he had a problem. His direct current systems were in trouble. He launched a bizarre campaign to discredit Tesla, even holding public electrocutions of animals to demonstrate the dangers of alternating current. But in the end, even Edison's wealth and reputation couldn't defeat the math and science. Tesla won. He solved the I²R problem. You won't have to look further than your front yard to see Tesla's alternating current in action. This transformer in front of our house is converting the very dangerous thousands of volts on the supply lines to less dangerous 120 volts for use in our home. Alternating current electrical grids cover the globe, delivering power from a multitude of sources through an interconnected network of transmission lines and transformers. This is Tesla's vision of electric power transmission realized.